Assalamu alaikum. In this series, Mr. Omar will guide you through some practice problems to cover all items included in the coverage issued by Emirate Schools Establishment, E.S.E. This is part 7. Have a fruitful time.
Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. Now we are still at question 17. We have here a question. A large cubic block of ice of mass m equals 64 kilogram and sides of length 0.4 meter is held stationary on a frictionless ramp. The ramp is at an angle of theta equals 26 above the rectangle. The ice cube is held in a place by a rope with visible mass and length L. The rope is attached to the surface of the ramp and to the upper edge of the ice cube at distance L above the surface of the ramp. Find the tension in the rope. Let us draw the diagram. Here is the ramp. And here is the cube. The cube is tied to the surface here. This rope has a length of L. Equals 1.6. And the height here is L.4, so we can find the angle theta here. Let us name it as alpha, and that one is theta. Now, for angle alpha, sine alpha equal opposite, which is 0.4, over the hypotenuse, 1.6. 0.25. And cosine alpha adjacent over the hypotenuse. What is the adjacent? It is 1.6 squared minus 0.4 squared, applying Pythagorean theorem. So this is 1.6 squared minus 0.4 squared. That 2 square root of 15 over 5. Put it here, square root of 15 over 5 divided by 1.6. The answer is square root of 15 over . Now we need to know the forces acting on this block. For the free body diagram, this is the x-axis and this is the y-axis. Here is the block. Its weight in this direction. The rope make an angle in this direction. This angle is alpha. This angle is theta. T. And we have the normal force on the y-axis. These are the forces acting on the cube. Rope, gravity, and normal, and no other forces. Now you need to resolve the forces on x and y. Here we have Fgx and Fgy. and we have tx and ty as well. This is tx and this is ty. Since there's no friction, we don't need to find the normal force. The question needs to find the tension in the rope. Now immediately go to Newton's second law. On x-axis, F net on x-axis equals m times a. On the x-axis I have fgx minus tx equals m times a. What is fgx? Fgx, it is fg sine theta, and fg it is mg. So fgx it is mg sine theta. For tx it is t cosine alpha, because the x-axis is adjacent to the angle alpha. Acceleration is 0 because the cube is kept at rest. Then t cosine theta, cosine alpha, should be equals to mg sine theta. That means t equals mg sine theta over cosine alpha. Now m is 64. G 9.8 sine theta, the angle of the incline, it is 26 over sine alpha. We don't know alpha, but we know the cosine alpha. Cosine alpha it is square root of 15 over 4. Square root over 15 over 4. Do the calculations. 64 times 9.8 sine 26 divided by that is 284 newtons. A 2 kilogram block is on a plane inclined at an angle 20 with respect to the horizontal. The coefficient of static friction is 0.6. How many forces are acting on the block? 3 forces. One due gravity, which is the weight, Fg. The other due the surface, it is the normal force. The other is static friction. Static friction. And no other forces. What is the normal force? I don't understand the question. What is the definition or the magnitude? If it is the definition, it is a force acting between two surfaces. One of them is try to push the other. But for a magnitude, we need to draw our system. Here is the incline. The angle is 20. We have the object, x-axis and y-axis. And this is the force FG and force. Now resolve FG, FGX and FGY. This is FGX and this one is FGY. Because the gravity tries to pull the object down, so here is tendency of motion. Tendency of motion. So against it we have the static friction, Fs. Now to find the normal force on y-axis, put F net on y-axis equals 0. We have only the normal force upward, and against it Gy. So the normal is Gy. Fg it is mg. Since it is in the y direction, we have cosine theta. Now put your numbers. M G 9.8, cosine the angle is 20. So it is 15.4. Is this block moving or why? We need to examine Fs maximum with the force that pulled the object. Fs maximum equals us times n. How much is mu n? It's 0.6 times Fn 18.4. The answer is 11.1 rounded. Now the force that against Fs, it is the Fgx. Fgx Fg sine Fg it is mg sine theta. M, how much m is 2, G 9.8 sine 26. 9.8 sine 26. Is 8.59. Check. Okay, now Fgx is smaller than Fs maximum, so no motion because the threshold start motion. Now for the solve problem 4.3, a wedge of mass 37.7 is held in a place in a fixed plane that inclined with an angle of 20.5 with respect to the horizontal. Let us draw the situation. This is the incline. The angle theta. Here is the wedge. The x-axis and and y-axis. We have the weight Fg, two components Fgx and Fgy. Fg equals m times g, 37.7 times 9.8, 37.7 times 9 is 369.46. Fgx equals Fg sine theta, so 369.47 sine 20.5 129.4, and Fgy equals Fg sine theta, 369.46 sine 21.5. The answer will be 346. Now we have a push here, force, but I need to draw it from the origin. It's better. So this is the force F, and this is the angle theta as well as that one down. Now here we have Fx and Fy. Fx, it is adjacent to the angle, so it is F cosine theta, and F is 301.3 cosine 20.5. So it is 289.7, and Fy equals F sine theta, 309.3 sine 20.5. Answer 18.3. Now we need to compare the forces parallel to the surface with each other to see where is the motion. Look, Fx equals 289.7, while Fg of x equals 129. We see that Fx is greater than Fgx, so the motion is toward Fx to the top of the incline. So here is the motion. Hence, the friction will be in this direction. So this guess is to find the friction force. Where is it? Is it up or down? Now we need to find Fk. It's easy. On y-axis, put F net on y equals 0. Y-axis we have the normal force upward like this, and Fgy and Fy downward. So n minus fgy minus fy equals 0. Then n equals fgy plus fy. fgy 346.1. fy is 108.3. So the answer is 464.4. Since you get n, you can find fk. fk equals mu k times n. Mu k, it is 0.171 times 454.4. Okay, times 0.71. This is 77.7. This is the friction. Now go to x-axis. On x-axis, put Newton's second law. On x-axis, we have three forces: Fk and Fg to the right, Fx to the left. So Fk plus Fgx minus Fx equals n times k. Fk, it is 77.7. Fgx 129.4. Fx 289.7. The mass 37.7 times k, and you can find easily the acceleration from this expression. And it would be minus 2.1 meter per second square. This minus means up to the top of inclined. Now for 4.9, we discussed this question before, the first part. So see video part 1. I don't know why the coverage repeat this here. Is it important or what? I don't know. So the two problems, these two problems, we discussed it earlier in part 1. Now 4.4, a shipping cart that weighs 340 newtons. This is Fg. Is initially stationary on a loading dock. A forklift arrives and lifts the crate with an upward force of 500 Newton. This is Fa, applied force. Accelerating the crate upward. What is the magnitude of the force due gravity? The force due gravity, it is the weight. This is the definition of the weight. And the weight will not change if the position is changed a little. the weight will change if you move for very high altitude above the ground, above the earth. But if you go up 1 meter, 2 meter, 10 meter, 100 meter, your weight will not affect. So the Fg equals 340 Newton. That's it. This is the answer. He's asking about the force due to gravity. It is the weight, and the weight will not change due to this motion for a very low height. A block is sliding on a near frictionless slope with an incline of 30. Which force is greater in magnitude? The net force acting on the block or the normal force acting on the block? This is the inclined, and this is the block. X-axis, Y-axis. Here we have Fg, and this angle is theta. This angle is theta. And the normal force into the y-axis. Now find the components of the weight Fgx and Fgy. Fgx equals Fg sine theta, which is mg sine theta. Now Fgy equals Fg cosine theta, which is mg cosine. Now on y-axis, Fnet, the y-axis equals 0, so the normal force minus Fgy equals 0, and here we have N equals Fgy, which is mg cosine theta. Now on x-axis, we have Fnet x-axis equals n times a. If you look to the forces, the free body diagram, you will find that Fnet is nothing but it is Fgx, which is mg sine theta. Now to compare the normal force with Fnet, we want to divide one of them to the other, find the ratio, the net force acting on the block or the normal force. If we do the following, the normal force over the Fnet, the normal force is mg cosine theta, and the net force is mg sine theta. You can cancel mg, and you have 1 over tan theta. Sine over cosine equals tan theta. Then if you make cosine theta over sine theta, it should be 1 over tan theta. Now n tan theta equals F net. What is tan theta? It is tan 30. This means F net equals N tan. The angle in this question is 30, I think. Yes, it is 30. And tan 30 is almost 0.577. And then F net, comparing to the normal force, it is only 0.7%. So F net 7.7% of the normal. So the normal is greater than. A force of 5 newtons acts over a distance of 12 meters in the direction of the force. Find the work. MashaAllah. Alhamdulillah. Inshallah تجي الأسئلة. Work equals F d cosine theta. The force is 5 newtons. D 12 cosine. The angle is 0 because the force in the same direction with the displacement. So the answer is 60 joule. I hope all the questions like this. Measure your coach distance of 4 meters across the living room floor with horizontal force of 200. Force of friction is 150. What is the work done by you, by the friction, by gravity, and by net force? Question. Now, here is the floor, here is the coach. This is the initial position. And the final position is somewhere here. Where the distance between them is 4. Now, my force FA equals 200. The friction force Fk, it is 150. I need the work done by me, by friction, by gravity, by the net force. Now, FA dA cosine theta A, it is the work done by A. FA 200, D 4 meters, cosine, the angle is 0, so it is 800 joules. Now the work according to the friction is F friction, D under the friction, cosine theta under the friction equals the force of friction 150 times the distance is 4, cosine angle 180. So the answer is minus 600 joules. What is the work done by friction? By the gravity now. Work by the gravity equals Fg dg cosine theta g. And this is 0 because the angle between the distance and the force is 90. Finally, you can find the normal force. The normal force, d cosine theta for the normal source, and it is 0 because it is normal. Now the work net equals WA plus WK plus WG plus WN plus W other paper or something like that. This is 800 plus minus 600 plus 0, 0, 0. The answer is 200. It's 200.
Hope that this video has enriched you more. In the description box below, there are links to both a PDF document for answers and the other videos in this series. This is the end of part 7. See you in part 8. Salam.